So on lesson 6, they want us to use reduction formulae, which is this, and special angles to show that this expression can be simplified to sine theta. Okay, that's pretty simple. By now, if you have watched all the videos, I'm sure you can agree with me that it's pretty simple. I advise you to pause the video and try to solve it by yourself and check the solution to save your time, right? But provided you have watched from lesson 1 up until lesson 5, I'm sure now you should be really good with this. Okay, so let's proceed. So sine 180 plus theta, 180 is here, plus is here. So it's on the tan. So this part will be negative. So I'll have negative sine theta will not change because of the 180. Okay. Then I have multiplied by. Okay, guys, if you have a value that is way bigger than 360, right? You are going to minus 360s out of it, basically. Né? So 720 minus 360 is how much? It's 360, right? Then you minusing 360s is like minusing a 0 because we start here. So you're not really changing the meaning of the expression. Does it make sense? Perfect. So I'm going to minus another 360 there, which is 0. So here's like I have tan 0 plus theta, which is just tan theta, basically. So I have tan theta there. Okay. Remember we said negative theta is in this quadrant. So cos negative theta will be positive because we're in the cos quadrant. It's just going to be cos theta all over cos 90 plus, okay. Let's check. 90 plus, 90 is there, plus we in the quadrant of sine. So in the quadrant of sine, cos will be negative. And cos will change to sine because of the 90 degrees, right? Remember, if we have 90 and 270, we change. I mean, it's going to be not 90, sorry, it's going to be this, sorry. Going to change to sine theta, right? Then this negative will cancel that negative. This sign will cancel that sign. Tan is the identity, right? Remember, tan is sine theta over cos theta, then multiplied by cos theta. Right, and then this cos at the bottom will cancel with that one at the top. Then you left it sine theta. Then you have shown this, right? Perfect. Then now we can go to 6b. 6b, they say without using a calculator, determine the value of sine 570. Remember, I said if the number is way bigger than 360, you're going to minus 360, right? So let's see, if you press on your calculator, so I'm going to have sine. If you press 570 minus 360, that gives you 210. The 360s, you can always just take them out because it's like you're just taking a 0 since they are all in the beginning. Makes sense? Perfect. Now, when it's like this, it's easier to work with now. It's going to be sine. I see 210 is closer to 180 plus 30 degrees. So it's sine 180 plus 30, basically. 180 plus, we're in the quadrant of tan. So in the quadrant of tan, this will be negative. So negative. Right. And then it's not changing because it's 180. So it's just going to be sine 30 degrees. Then we all know that sine 30 is half, right? If you press on a calculator, it's a special angle. It's going to give you half. Okay, now we fine with this. We're going to go to question 7 now. Now go do number 7. Okay. So let's do 7 now. Okay. So on 7, they want us to prove that this side is equals to that side. This looks very interesting. Okay, so I'm going to try to do this. Okay, let's see now. I have cos. So this is my left hand side, right? It's going to be cos theta over 1 plus sine theta. Okay? Before we actually solve this, I want us to discuss this identity, the Pythagorean identity. The Pythagorean identity says sine squared theta, right? Is this plus cos squared theta equals to 1, right? But from this, I can do this. I can say sine squared theta is the same as 1 minus cos squared theta, of which I see that this is the difference of two squares. Ne? So this is I. This is the difference of two squares, ladies and gents. So I can say this here, basically. I can say 1 cos theta, and then I say plus, I say minus. Because this is a perfect square, is cos times cos, and also this is a perfect square, is 1 times 1, and minus in between, so it's difference of two squares, okay? And then similarly, I can do this. I can say cos squared theta equals to 1 minus sine squared theta, which gives a difference of two squares as well. It's going to be sine theta, then I have 1 minus 1 plus, right? Perfect. This part here is going to help us to solve this identity here. Okay, let's go back now. Okay, I see at the bottom, I have 1 plus sine theta, right? Okay, so which one do I have here? I have this part here. You see? And remember, this part is cos squared theta. And I see, okay, and on the right, there's cos theta. So obviously, I need to use this one. You see? Perfect. The only thing that I don't have is this one. But fortunately, with the knowledge of multiplication of 1, I can include this. So I can multiply the top by sine 1 minus sine theta, and also at the bottom. So here, ladies and gents, remember this will always cancel this one. So I'm not actually changing the meaning of this equation. Does it make sense? I'm not changing. So it's like I'm multiplying by 1 here. And which is very exciting because I see that, okay, the top also has that. You see, this part. Okay, good. So now I'm going to do this. I'm going to say cos theta, right? Then in bracket 1 minus sine theta. Then all over 1 plus sine theta, 1 minus sine theta. Okay, good. Remember we said the bottom is this part, which is cos squared theta. So I'm going to have cos theta, 1 minus sine theta, all over cos squared theta. Then cos squared theta goes once into itself, it goes cos theta times into cos squared theta. Because remember, cos squared theta can be written in this form, actually. It can be written as cos theta times cos theta, you see? So one of them will cancel, then you're left with 1, which is 1 minus sine theta over cos theta, and which is equals to right-hand side. And you've proven that, ladies and gents. And that's finito. Thank you very much for your time. Please don't forget to share with family and friends and subscribe to my YouTube channel. Thank you very much.